Hi everyone, welcome to the CSS3 course. In this video, I'm going to discuss a topic called Flexbox. So in my previous video, I have already discussed some basic properties of a Flexbox. So in this video, I'm going to continue the discussion of Flexboxes by including the ways to determine the growth and shrinkage of the items in a given container when I have set up the Flexbox properties correctly. So before I discuss the Flexbox properties in terms of shrinkage and growth, let me show you the HTML file first. So the HTML file is simply corresponding to the web page on the right-hand side. So for the web page on the right-hand side here, you can see there are so many items, and some items are overflown because the total sizes of the items when combined together is larger than the container size. So after some discussion later, I'm going to handle the items so that they can be put inside the container by means of appropriate shrinkage or growth. So for the other parts of the web page, I'm going to discuss many topics by setting up some of the conditions of the Flexbox properties. And for different combinations of the Flexbox properties, I'm able to see the effect of the shrinkage and growth of different items in different combinations of the Flexbox properties. So in order to create this web page, I'm going to show you the HTML file. So you can see in the HTML file that it contains a lot of divisions, and in each division, I'm going to set up some inner divisions that is shown by the division text, and usually the division texts are containing some words, and when I go further, I'm also able to see similar structures of my HTML file. So it contains some container division, and inside the container I have some items which are usually words, or sometimes it can contain some longer sentences, like this one, okay? And let me show you further. So the idea is to include different combinations of the Flexbox properties that can help me discuss the ways to do the growth and the shrinkage of the items in the given container. Also, let me show you my CSS file. So the CSS file simply helps me to determine the container size, and when I highlight the container component, you're able to see the highlighter given by the brackets editor. And inside the container, usually I have some divisions, and the divisions are usually sized and colored. And I'm going to do the shrinkage or growth in each of the items in a given container. So let me go further to let you see more containers and the corresponding divisions inside this particular container. So I'm going to do a lot of calculations in order to help me understand the ways to do the shrinkage and the growth of particular items in a given container. I'm also telling you the way to evaluate the shrinkage and growth effects. Okay, so you can see different combinations of the Flexbox properties, and I'm going to investigate some of the combinations, and you are able to learn from the combinations how we handle the Flexbox properties in terms of the growth and the shrinkage. Okay, so let me go to the beginning of the HTML file, as well as the CSS file. So we already understand that a Flexbox is simply a one-dimensional layout model that stores items, and a Flexbox allows wrapping and space distribution between items. This is something we talked about in the previous video. And for this video, I'm going to talk about how we can allocate the free spaces for the items so that they can be aligned inside the container pretty well. So let me go to the first container and let me set up the Flexbox first. Okay, I'm going to do the wrapping for the items inside this container. So for this container, I have already got 3 items, and for simplicity of the calculation of the dimensions, I already set up the border box as the value of the box sizing property. So the width of each item is simply 90 pixels. So this 90 pixels include the border width, the padding, and the content. Okay. So you see I have already included the border width and the padding. So the box sizing property helps me to include all these borders and padding into the 90 pixels for my width. Okay. So let me go to individual items. So one way to do the sizing is by means of the flex spaces. So what does it mean by flex spaces? Let me show you the attribute value pair. So for example, the flex spaces can be set as auto. So what does it mean by this one? A flex spaces is simply the dimension that your shrinkage or growth is based on. So when I set auto as the value of the flex spaces attribute, it means that I'm going to handle the shrinkage or growth with the element size being my basis. So because my items have got a fixed size, which is 90 pixels, so I already understand the amount of the element size. So in this case, when I use the auto value, it just means that my flex basis is simply the entire element size. And if you haven't got any element size, for example, when you have an auto-sized item, you just follow the content size of your item. So what is the content size? The content size is simply the words inside the item. So when you don't do the appropriate sizing explicitly, you will base on your words inside your container as your flex spaces. Okay. So I can do similar things for my remaining 2 items inside this container. And for the third one, same flex spaces being auto. Okay, so I've already set up the basis in which I calculate the growth or the shrinkage of the items when it comes to the distribution of the free space. So I can do something more now. I want to determine the growth of the particular item. Okay, so I already set up flex grow attribute being equal to 1. So you can see that item 1 has already increased its width very significantly. And I can do similar things for items 2 and 3, and I'm going to explain the corresponding growth later. Now I set up item 2 to have a flex grow value of 2. And for item 3, I set the flex grow value to be 3. So what does it mean by these values 1, 2, and 3 for each of the items? Let me explain it now. So for flex grow being equal to 1, it is helping me to allocate the free space available for each of the items. So now you can see that the flex growth ratios are 1, 2, and 3 respectively. So it means that I'm going to allocate my positive free space according to this ratio. So what does it mean by the allocation of free space? Before we do the allocation, we need to find out the free space available across the entire container. So what does it mean by the available free space? We can check the dimension of the container first. The container has a width of 480 pixels, and we already know that the width of each item is 90 pixels. So altogether, we have this amount of available free space for you to distribute. So 480 minus 270 equals 210 pixels. So it means that you have 210 pixels that are available for you to do the space distribution. So when I set flex scroll to be 1 for item 1, I can have one portion of the available free space. So when we do the proportion, we know that we have altogether 6 portions for the entire container. And how can we know it is 6? It is simply equal to 1 plus 2 plus 3. Okay. So for one portion of the available free space, it just means that I'm going to take 1 out of 6 available portions of the free space, which is equal to 35 pixels. So it means that the item 1 has got 35 pixels of the positive free space to be added. So it means that in addition to my original size, which is 90 pixels for each item, the width of item 1 becomes this amount of value, which is equal to 125 pixels. Because originally it was 90, when I add up the proportionate free space to item 1, I will have 35 pixels more. So let us go to item 2. For item 2, we can see that the available free space that can be added to the item is simply equal to 70 pixels, which is equal to the available free space times 1/3, which is equal to 2/6. So in this case, in addition to the original width, the amount of width is simply equal to 160 pixels when I add up the positive free space to the original size of the item 2. So for item 3, we can see that we have 105 more pixels to be added. So in this case, the width of item 3 becomes 195 pixels. If you are not sure of the calculations, you can always check it out by using the developer tools of your browser. More tools, developer tools. Okay, so that we select the container, and inside this container, I am able to see the width of each of the items when I just put my cursor on top of each of the divisions. So for the first item, I have 125 pixels as the width, and for the second one, I have 160 pixels, and for the third one, I have 195 pixels. So this is the way how we allocate the free space for each of the items. Okay, so this is the situation when I set up the flex spaces to be auto, and I allow the flex growth for each of the items inside the container. And we also have the sized items for me to allocate the spaces. The size is simply given here. Okay. So let me talk about another topic called flex spaces being equal to 0. So let me go to the corresponding HTML file. So for this situation, when the flex spaces is 0, it is a bit different from before. So before doing so, I set up the Flexbox for this container first. Okay, I allow the wrapping. And I also set up the border box as the value of the box sizing attribute. That means the entire width of this item, including the borders and the padding, is simply equal to 90 pixels again. Now I'm going to set the flex spaces first. Now you see that flex spaces is equal to 0. So when the flex spaces is simply equal to 0, we simply treat the item as having no size. We don't count 90 pixels. Instead, we treat the size as 0. So in this case, the proportion of the available space shown here will be calculated in proportion to the content size. So what does it mean by the content size? The content size is simply the space occupied by the content alone. So we exclude the padding as well as the borders. So that is the meaning of the content size. And I can add something more. Okay, I'm able to set up the flex scroll attribute to be 1. So when I want to do the arrangement of the free spaces, I have to notice that the content width is simply equal to this amount for each of my items. Why? Because for my width, it is 480 pixels for my container size. And I have one border on one side and one padding on one side. So the padding and border contribute 10 pixels, okay? So 10 pixels here and 10 pixels there. So one border is already including 10 pixels, and two sides of the padding amount to 10 more pixels. So we can see that when I have 3 boxes shown here, the amount of the free space is simply 60 pixels less, because I have to exclude the border for each item and the padding for each item. So when I have both sides to be considered for each item, we have altogether 60 pixels of the border width and the padding. So in this case, when I do the content size, I have to deduct the border size and the padding size from the available container width. Okay, so when I subtract the border and padding size from the container width, I have only 420 pixels for the available size, because I set up the flex spaces to be 0. So in this case, I simply treat 420 pixels as my free space. So in this case, I can do something further by including the flex scroll and flex spaces values for items 2 and 3. I want to have 2 for item 2 and 3 for item 3. Okay, when I have the ratio as follows: 1 to 2 to 3, I'm able to calculate the content width for each of the items. So for item 1, the content width is simply equal to one portion of all the 6 portions calculated by summing up all the scroll values. Okay, so I have 1 out of 6 being the content width of item 1. So you see item 1 is simply equal to 70 pixels in terms of the content width. So the item width is simply equal to 70 plus 20, which is equal to 90 pixels. Why do we need to add 20? Because I have to add up the border width for both sides and the padding width for both sides. So that's why I have 90 pixels. So for item 2, the idea is quite similar. Now I can allocate 2 out of 6 portions of the available free space. So in this case, I have 140 pixels. And when I have the content size, I'm able to find out the item's size by adding up the borders as well as the padding on both sides. So item 2 becomes 160 pixels. So for item 3, the idea is similar. The content width becomes 210 pixels because I can have 3 out of 6 portions of my free space. And then the item width is simply equal to 230 pixels because the content width has to be added with the border width on both sides and the padding width for both sides. Now let us see another situation shown here. Now I'm going to handle the situation of long-sized items. So what does it mean by long-sized items? Now you can see that in my division style sheet, I don't set up any size of my items. So you can see that for now, the items would simply occupy the entire viewport width. Okay, so let me set up the Flexbox first. Okay. And after I set up the Flexbox, you can see that the size is already changed. Now for item 1, I just get the width which is equal to the max content size of my item. And for item 2, I get the width being the max content size of the item. Same for item 3. So when I don't do anything to do the growth or shrinkage of the free space, I'm able to get the max content being the item size. And then when I want to do available space distribution shown here and here, I'm going to handle each of the items. Now I set up the flex spaces of item 1 to be auto. That means I'm going to take the element size if any. But now we don't have a fixed size for my item. So in this case, I will get the maximum content size being the flex spaces. Okay. And now I set up the grow factor to be 1. And I do the same thing for item 2 now. But now I change the growth factor to be 2 for item 2. So now you see that items 1 and 2 are already able to distribute all the free spaces. So you can see that for item 1, the size is increased a little bit. And for item 2, the size has increased a bit more than item 1 does. Okay? So what does it mean by this situation? How can we explain the situation? We can have the explanation shown here. Now items 1 and 2 stay on the same row, so they can share the positive free space on the entire row. Okay, so what does it mean by this one? When we do the wrapping shown here, when the item has changed to another row, this element is able to share the free space corresponding to the entire row. But for items 1 and 2, they have to share the free space available for that row only. So when I ignore the growth, you can see that originally they have only this amount of free space to be available for both of them. So when I set flex grow to be 1 for item 1 and flex grow to be 2 for item 2, we can see that the available free space is shared according to the proportion 1 to 2. So this part is simply one of the 3 portions of the free space along this row, and that part is simply 2 of the 3 portions of the free space on that row. Okay, so we can see that items 1 and 2 share the positive free space on that row. And how about item 3? You can see that item 3 is wrapped to another row. So in this case, you can expect that item 3 is able to obtain the entire free space on this row. So let me see the effects now by including the flex properties with item 3. Okay, now actually we don't need to put 3. We can put any number, because no matter how large or how small this number is, item 3 is able to occupy the entire row. So the free space will be allocated to the entire item. Okay, so when wrapping occurs on another row, we simply treat the wrapped item as another separate flex item. The word separate is important here. So we can treat this one as separate, and the previous allocation of the free space to previous items do not affect the allocation of the free space on this wrapped item on another row. That is the basic idea. Now we see another situation that includes flex spaces of 0, and we want to grow the size on non-sized items. Non-sized item simply means that we don't set up a specific size for each of the items. So let me go to the CSS file and also the corresponding HTML file. So for this one, I simply set up the Flexbox first. Okay, after setting up this Flexbox, you can now see that the items would have the max content being the size, because I don't explicitly set up the division size. Now I'm going to set up the flex spaces for each of the items, which is equal to 0. Now you can see that when I set flex spaces to be 0 for all of the items at this stage, you can see that the width of each item is simply equal to the mean content size. Okay, so the mean content size is simply determined by the longest word in your item. Okay, this is the meaning of the mean content size, MINCONTENT. Okay, so now when I want to do the growth of the items, when I want to do the allocation of the free space to each of the items, I can do something similar now. 1 for flex 1, 2 for item 2, 3 for item 3. So when I set up the ratio as follows, 1 to 2 to 3, what does it mean by the allocation of free space? So if the flex spaces is equal to 0, we simply treat the item as having no size. And then we calculate the size according to the content size. So again, we can go back to the definition of the divisions shown here. For each division, I include the border width and the padding. So you can expect that there are already 20 pixels for the padding and the borders for each of the items. So the width is already 20 pixels less for each item due to the inclusion of border width and padding. So altogether for these 3 items, you can expect that there are 60 pixels of padding and borders being removed. In this case, I will get the net content size for my entire container, which is equal to 420 pixels. And now I want to share one portion of the content width, which is equal to 70 pixels. Why 70? Because I need to do 1 over 6. And here 6 is simply equal to the total proportions. 1 plus 2 plus 3. Okay, so that's why I will have the content width being equal to 70 pixels. And now I can include the borders and paddings, so that the item width for item 1 is simply equal to 90 pixels. Okay, so for item 2, I can do similar things. When I do the content width, I don't have 70 pixels, I will have 140 pixels, because I take 2 portions out of 6 for my remaining width, which is equal to 420 pixels. So in this case, I will have 140 pixels plus 20, which is equal to 160 pixels for my size of item 2. So for item 3, I can do the similar things, but now the portion is 3, so that the content width becomes 210 pixels. And the content width together with the border width and padding width would be equal to 230 pixels for item 3. So that's why I can get the dimensions quite precisely according to the flex grow proportions for each item. Okay. Now let us go to another topic called shrinkage. So when we have positive free space, we can put the free space to the items. But how about the length of the items being overflown? It is possible. So let me see the example shown here. So let me go to this component of my CSS file, and I'm going to show you the container, which is this one. Okay. So I'm going to discuss this part. And now let me set up the Flexbox first. Okay. Now you see that the items are put inside the container. So when I simply choose the container, you can see that the container is able to occupy all 3 items. Okay, all the 3 items are stored in the container. And when I do something more, I can show the shrinkage even easier. Now I set up the flex spaces to be auto. That means I would take the element size as my basis of the calculation of my shrinkage. Same for item 2. Same for item 3. So I can also set up the shrink factor called flex shrink. Okay, if I set up 0, that means I don't do the shrinkage. So I will maintain the entire width of item 1 to be 200 pixels. Because I use border box as the value of the box sizing property, it means that 200 pixels include the border and the padding. Same for item 2. So you can see that item 2 also has 200 pixels as the width. Now, item 3 is also having 200 pixels. So in this case, you can expect an overflow of the items. So you see when I simply choose the container, you can see that the content is overflown. The 3 items will have a larger area than the container. Okay. So in this case, when we don't do the shrinkage, we simply set up every single item as having a shrink ratio of 0. And then when I want to do the shrinkage to eliminate some space from each of the items, we can follow some similar idea as what we did for the growth ratio. Let me change to 1 for item 1, 2 to item 2, and 3 for item 3. So when I change the ratio to 1 to 2 to 3, what does it mean by this idea? I'm going to show you now. So when we have the ratio of 1 to 2 to 3, it means that I'm going to allocate the negative free space proportionally to each of the items. So what does it mean by the negative free space? We can see the formula now. Initially, we have 480 pixels for the container width, but for each item, we have 200 pixels. So altogether, we have 600 pixels for the width of all the divisions. So you can expect that I have 120 pixels of overflow when I want to put all these 3 sized items into the container. So in this case, the container is overflown, and we can say that we have this amount of overflown space, which is called the negative free space. And if I want to put all these items into the container exactly, then we have to remove some space from the original items. So how much space is removed for each item? We have a formula to calculate it. So we know that we have only 120 pixels of negative free space, or the overflown amount of space. Then we share the proportions appropriately with 1 to 2 to 3. So for item 1, I will have 20 pixels to be removed. So in this case, item 1 becomes 180 pixels wide. Okay. And for item 2, I need to remove 40 pixels because of the proportion issue. And now item 2 becomes only 160 pixels wide. And for item 3, I need to remove even more pixels of 60 pixels, you see. So in this case, item 3 has only 140 pixels wide. So you can also check the values of the width with your developer tools. More tools, developer tools. So let me go to the corresponding division here. And when I put my cursor on top of each item, you can see that the item width for each item is shown. For item 1, I have 180 pixels. For item 2, I have 160 pixels. And for item 3, I have 140 pixels. So that is the reason why we can calculate the space proportionally according to the allocation of the free space with the shrinkage factors for each item. Okay. Now let us go to another part. When the flex basis is 0, how can we do the shrinkage? We can have similar idea. So let me go to the component for my CSS file and the HTML file. So let me set up the Flexbox first. Okay, I allow the wrapping. And I already set up the width for each item to be 200 pixels. So initially the size is 200 pixels for each item. So you can also expect an overflow of 120 pixels because my container width is simply equal to 480 pixels, and I'm unable to cover all the widths for my items. Then I go to the flex basis issue for each item. If I set up the flex basis to be 0, it means that I just treat every item as having a width of 0. And then I'm going to share the width according to this flex basis. So for now, all the 3 items would have the flex basis equal to 0. It means that the items will simply shrink to the min content size. So the min content size is simply determined by the longest word in each of the items. So for items 1 and 2, they will have the same width because they are simply based on the word item to find out the mean content size. And for item 3, the mean content size is larger because I just based on the word contains as the mean content size. So how about the situation when I include the flex shrink value? Let me see. For item 1, I set up the flex shrink value to be 1. For item 2, I set it to be 2. And for item 3, I set it to be 3. So you can see that the flex shrink attribute value pair is unable to help you change the effect. So when we set flex basis to be 0, we simply base on the mean content size as the width of your elements. Okay, so the proportions don't work in this case. Now let us go to another situation of the shrinkage of the non-sized items. So let me go to this portion of the CSS file, and let me go to the portion shown here for my HTML file. So of course, I have to include the Flexbox first. Okay, when I want to do the wrapping, you can see that items 1 and 2 would have some free space at the end, and item 3 would have no free space shown to you. And now I don't set up the width of my items because I don't set up the width explicitly. And in order to do the shrinkage of these items, we can do something like this for item 1 first. I use auto as my flex basis. That means I will simply use the max content for my basis when I don't really have the explicit width for my item. Same for item 2 and the same for item 3. And how about setting up the shrinkage ratios for each item? Let me try now. Flex shrink equals 1 for item 1. flex shrink equals 2 for item 2, and flex shrink equals 3 for item 3. So you can see that the effect is unaltered. So when I set up the flex spaces to be auto, when we handle non-sized items, we simply take the max content size, unless your size is already constrained by your container size. So if you think about taking up the max content size for item 3, you will expect that there is an overflow of the container. But we don't expect it in this way, because for this situation, the size of item 3 is simply confined by the container. Okay, so this width is simply equal to the container width, which is 480 pixels. So for item 3, we don't have the overflow condition. So this is the idea of having flex spaces being auto. So that is the idea of having the flex spaces being auto. Okay. Now let us see another situation of flex spaces being 0. How can we do the shrinking for non-sized item? That's the topic of this portion. So then we go to the CSS file and the HTML file. Okay, so I set up the Flexbox first. Okay, I include the border width for my container, so it is able to help you visualize the effect a bit easier in this case. So you can see that items 1 and 2 are placed on the first row, while item 3 is placed on the second row. Okay. Now let us see the effect of having flex spaces being 0. So for flex spaces being equal to 0, we just allow the size to be equal to the mean content size. So you see, item 1 has this word being the longest word, so that the mean content size is simply based on this word length. So similarly, I can do the same thing for item 2, and same thing for item 3. So in this case, I just changed my comment to this one. So when the flex spaces is equal to 0, it just means that I follow the mean content size. And how about adding the shrinkage ratios? For item 1, I set it to be 1. For item 2, I set it to be 2. For item 3, I set it to be 3. So you can see that the width of the non-sized items are not affected by the shrinkage ratios. They just follow the mean content size. Okay? And you can also see that the overflow would occur along the cross-axis. That means on the vertical side, there is overflow. Why? Because for item 3, you can see that there is a very long sentence, and the long sentence isn't able to be covered by the container height. Okay, so in this case, the overflow along the cross-axis will occur. Remember, my flex direction is row, so the cross-axis is simply the height instead of the row. Okay. Now let us go to another part called the flex shorthand. So in my previous examples, I usually include flex spaces and flex shrink together. And in my even earlier examples, I include flex spaces and flex grow together. So it is not quite convenient when we simply include only 2 of these 3 values. Usually we can just include all these values in one row. So how can we do that? We can simply use the shorthand form. So let me go to the corresponding part. This one. Okay, and let me go to the corresponding HTML part. Okay, for this part, let me set up the Flexbox first. Okay, now you can see that the 3 items are placed in this way. You see, the width of the items is 200 pixels, so you can expect that they cannot be put in just one row inside my container. So you can see that when I choose the container, you can see that there is some free space along the first row and the second row. So how can we distribute the free space? We can simply make use of the shorthand form as follows. Okay, when I use flex keyword, we follow the rule shown here. The first value refers to the flex grow factor. The second value refers to the flex shrink factor. And the last one is simply the flex spaces. So 1 auto means that I use a ratio of 1 for my growth, ratio of 1 for my shrinkage, and the flex spaces is simply equal to auto. So for my case here, the width is fixed. That means I follow the element size of 200 pixels. So I can do similar things for items 2 and 3, and I'm able to see the effect when I set up the 3 items in this way. So for item 2, I have the growth ratio of 2 and the shrinkage ratio of 2, and the basis is also 0. So for item 3, I set the growth ratio to be 3 and the shrinkage ratio to be 3 as well. For the flex spaces, it is auto. So that means it will follow the element size, because the size of each item is set as 200 pixels initially, shown here, okay? So when I have 1 to 2 to 3 for my flex grow proportion, we can see that the space is calculated as follows. Initially, we know that items 1 and 2 would occupy the entire row, and item 3 will occupy another row, okay? So in this case, we can handle items 1 and 2 together, because the free space on that row will be shared by the 2 items only. So when the flex spaces is set as auto, we want to find out the positive free space for items 1 and 2. How can we do so? Since we know that for each item, it was initially 200 pixels wide. When we have only 2 items on one row, we can expect that we have only 80 pixels available for the 2 items to share when I set the flex window size as 480 pixels. So this 400 is simply referring to the width of the 2 items. So altogether, we have only 80 pixels to be shared along the first row, okay? So for these 2 items, we simply follow the ratio of 1 to 2. So for item 1, it can have 1 portion of the free space, which is equal to this amount of pixels. And for item 2, we have this amount of pixels, because it is calculated from this formula, which is equal to 2 of the 3 portions of the free space along that row, okay? So after adding the original width, we can see that the width of item is equal to 226.67 pixels. And for item 2, the width is simply equal to 253.33 pixels. So we can also check the values with your developer tools. More tools, developer tools. Okay, let me show the division. And when I put the cursor on top of the first item, we can see that the width is simply equal to the calculated amount. And for item 2, we also know that the width is equal to the calculated amount. So how about item 3? Item 3 is a bit different, because item 3 can make use of the entire free space on that row. It just means that item 3 can span the entire second row. It takes up all the available positive free space. So for the container size, which is equal to 480 pixels, it just means that item 3 has a width of 480 pixels. We can go back to the developer tools. Yes, the width is simply equal to the container width when I just consider item 3, which is wrapped to another row, okay? Okay, we can also see the effect when the flex basis is equal to 0. So let me go to this component of my CSS file together with the CSS HTML file shown here. As always, let me set up the Flexbox first. And now I'm going to set up the flex basis. So you can see that before I do the flex basis change, each item is equal to 200 pixels wide. And since item 3 is too long to be put along the container, which is only 480 pixels, you can see the wrapping. Okay. So I can set up the flex basis to be 0, and I have the growth factor of 1 and the shrinkage factor of 1 for item 1. So for item 2, the flex property has 3 values of 2, 2, and 0. And for item 3, the flex attribute has 3 values, 3, 3, and 0. So when the flex basis is equal to 0, we just treat the item as having no size, and then the free space is calculated based on the content size only. So let me see the content size. The content size is calculated by some kind of subtraction. So we see that we already include the border width of 5 pixels on both vertical sides, and we also have a padding of 5 pixels for both vertical sides. So altogether there are 60 pixels to be eliminated from the content size. Okay. So we have only 420 pixels being the free space for you to do the allocation of the free space, okay? So in this case, I will get 70 pixels being the content width for item 1, because I just take 1 out of 6 portions of the available free space. So the content width is simply equal to 70 pixels. And after adding the padding and the borders, I will have 90 pixels being the element size, okay? So for item 2, I have 140 pixels being the content width, because I can take 2 out of 6 portions of the content width when I set the flex basis to be 0 for all the items. Okay. So in this case, item 2 has a width of 160 pixels because after adding up the borders and the padding, the content will be wider. Okay. And for item 3, I have 210 pixels being the content width because I can share 3 out of 6 portions of the content width. And then the item 3 would become 230 pixels wide because it also includes the 2 borders and the 2 paddings vertically. So this video has discussed a number of evaluations when it comes to finding out the allocation of the free space into each of the items. So the basic idea is as follows. We need to set the flex basis, and we have to set the growth or the shrinkage factor for each item. And we have to take care of the sized items or the non-sized items differently. Sometimes we have to notice that the max content size is used, or sometimes we simply use the mean content size as our basis, okay? And it is quite impossible to demonstrate every single combination of these Flexbox properties. So after this video, I hope you're able to understand the mechanism of finding out the free space allocation or the free space removal, so that you're able to expect what you will get when you use the properties differently. This is the end of the video. If you have any questions about my video, please leave your questions on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.